And greetings once again and welcome to Edu-ca-te. Today we're going to be talking about stable and unstable atoms. Okay, so how do we notice something is a stable is a stable or unstable atom? Okay, so you can see this is an atom of lithium here. You can identify that by just looking at the number of electrons, which is equals to 3. So that's a lithium atom. And then it's called an unstable atom. But then we'll see why. Here is an example of a stable atom. Helium. Helium is stable in this way. Okay, so what is this meaning of stable and unstable? So the atom that has got its valence shell more filled with electrons, with all electrons, it means it's more stable compared to others and cannot react with any other element. So this brings us to this. What is the valency thing theory? If you have watched our video on the valence electrons, you would understand. Therefore, I recommend you to watch that one before you proceed with this one. So you can see this is called the valence shell. This is called the valence shell because it is the outermost shell where we find the valence electrons. We can see that we only have one electron over there in the valence shell for the lithium. And then for the helium, this is the valence shell for the helium. So for helium, we've got 2 electrons. Here we've got what? 1 electron. So how do we identify that something is stable or not? So we see by the filling of the valence shell. Okay, you remember when we were doing an introduction to the atom, we say the capacity of the first shell is equals to 2 electrons. So it means it can hold up to 2 electrons. The second shell can hold up to 8 electrons. So the first shell is 2 electrons, the second is 8 electrons. So this means if we are going to check out here, you can see that the second shell or the second orbitals, remember the orbitals are these rounded things. So this is the first one, and then this one which I marked in red is the second one. So the second one for lithium is supposed to fill in basically 8 because it is the second shell. Its maximum holding capacity to hold electrons is 8. Therefore, you can see that in lithium it's not fully filled, meaning that it's not filled with 8 electrons. Therefore, it has to be filled. So the fact that it is not filled with 8 electrons, I mean the second shell, which is this one which I marked with red, then it means it's unstable. Okay, let's do a comparison with the valence shell here of helium. You can see that helium here, the valence shell here, it is filled. It can hold up to 2 electrons as we indicated. Therefore, the fact that it holds the maximum number of electrons it can, then it means it is a stable atom. So stable atoms, here is something you need just to write down, that stable atoms do not make any compounds with any element, with any atom or any element, with any atom. So they do not make any compounds with any atom. They just are stable. They are called stable gases or noble gases. You can find that in the periodic table. Here at group number 18, we have got all the stable or noble gases. You never find any compound that has got neon and argon or chromium, all of those. So here, I don't mean chromium, I mean here, helium cannot react with any because it has got its valence shell filled with electrons. So how do we determine that something is a stable gas? Is if its valence shell, this shell, the outermost shell, if it is filled with its maximum number of electrons. So this is what you need to know. So this stimulates the ions. So this stimulates the ion exchange. So what are ions basically? So ions or ions, I don't know how really it's pronounced in many different countries, but then an ion any atom or group of atoms that bears one or more positive or negative electrical charges. So you can see that, for example, here, if we have the lithium atom here again, would have here 1 electron, 2 electrons, and then the third one here. So it means this, since its valence shell is not filled with electrons, it will be stimulated to stabilize. So it would want other electrons to fill its outermost shell. So you can see that lithium here has got 1 electron in the valence shell, of which the valence shell for lithium is this shell, which is the second shell. So this can hold up to 8 electrons, but then it has got only 1. Therefore, it means lithium needs 7 electrons to fill its outermost shell. But then, because this electron over here for lithium is unpaired, or this electron is only 1 here for lithium, then it means it can lose that electron. So when making a compound, it can lose that electron. So that's why the ionic charge for lithium is plus on top. So this plus, it means it has got excess protons, and it's got a deficiency in electrons when it's transferring its electrons during a compound. So let's try to practicalize this. Okay, let's go to the periodic table and see and take oxygen for an example. Here is oxygen. Oxygen, if we are going to draw its atomic structure or its atomic diagram, oxygen has to have something like this. Here it is, 1, 2, 3, 4, 5, 6, 7, 8. No. Let's just check out the number of electrons in oxygen. Yeah, 6. So here we've got 1, 2, 3, 4, 5, 6, 7, 8. We've got let's see, 2, 4, 6. Let's just check out the number of electrons. So here, this has got 16. Therefore, the number of electrons is 8. So the number of electrons is 8. So this is the atomic structure for oxygen. So you can see I've got 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 electrons. Reason being, the mass of oxygen is 16. The atomic number is 8. The atomic number is 8. Therefore, the number of electrons is the atomic number, which is equal to 8 electrons. Therefore, you can see that the valence shell for oxygen is not completely filled. The valence shell is this shell here for oxygen. It's supposed to have 8 electrons in total, but then it has got only 6. So it means it has got a shortage of 2 electrons. Therefore, it needs, for it to maintain a stable structure, it needs to gain 2 electrons. Therefore, the ionic charge is 2 minus. This 2, it means this minus is standing for the electronic charge. Remember, the electronic charge is the negative charge. That's why we represent with a minus. And then this 2 is representing the number of electrons needed for oxygen to maintain a stable structure. Here for lithium, there is only 1 electron here, this electron at the second shell, of which for lithium to have a stable structure, it has to lose this electron so that it remains with this structure with only 2 electrons out there. So this is basically the lithium ion. This is the lithium. This is the lithium ion because it has lost 1 electron. Why did it lose 1 electron? To maintain a stable structure. Now the structure is stable in this way. So a lithium ion here it is. So this ion has been as a result of the losing of an electron here. So why did it lose an electron? So that this shell must remain with 2, so that this shell does not exist anymore. And then when this first shell has got 2, then it means it's now stable, just like helium. So this is the lithium ion. So if we're going to take the oxygen, so oxygen must gain 2 electrons. Therefore, for it to gain 2 electrons, it has got to meet another atom which has got 2 electrons, or 2 atoms which has got 1 electron each. So let's just go to the periodic table. So you can see that the periodic table here, hydrogen has got only 1 electron. Lithium has got 1 valence electron. One valence electron. Sodium, 1 valence electron. Potassium, 1 valence electron. All the elements in group 1 have got 1 valence electron. Therefore, oxygen needs to gain 2 electrons to fill its valence shell. Why does it want to fill its valence shell? Is because it wants to maintain stability. It wants to maintain a stable structure. Therefore, what needs to happen here is for oxygen must react with two atoms of hydrogen to form H2O. That is why you have got oxygen and 2 hydrogens. The reason for 2 hydrogens is because if hydrogen brings in 1 valence electron and then another hydrogen brings another, then the total is 2. Therefore, this total will be added here for the oxygen atom, and then it will be now stable. So for oxygen to stabilize, it has to meet a hydrogen which is twice, or a hydrogen which is 2 times. 2 of hydrogens. So that's the very same for every element that is on group 1. Oxygen can also react with elements on group 2. So if you can see elements on group 2, in group 2 here, elements here have got 2 valence electrons because it's group 2. 2 valence electrons. So it means that they are in shortage of 6, so they can lose those 2 electrons, of which oxygen needs 2 electrons to fill or to stabilize its outermost shell, or the valence shell. Therefore, oxygen can meet with beryllium. We don't have to have 2 of berylliums because beryllium has already 2 electrons. This one needs 2 electrons. Oxygen needs 2 electrons, but then beryllium has 2 electrons. 2 electrons in the valence shell, and those electrons are going to be lost, and they are going to be given to the oxygen to maintain its stable structure, and then it becomes a stable compound, beryllium oxide. Yes, basically beryllium oxide. So here, that is just how you calculate. This is just a basic way of looking at the ions. So the ions are just basically this exchange system. So let's just look at it. Here we've got a sodium atom, we've got a chlorine atom. So electron is transferred from the sodium to chlorine atom. So this is the sodium. You can see that a sodium is in group 1. Let's go back to our periodic table. So a sodium is in group 1. So it has got 1 valent electron. 1 valent electron. So that 1 valent electron is going to be lost from sodium. So that's why sodium has got an ionic charge of Na+. It means this loses 1 electron. It's got the excess proton. This plus is standing for excess protons. So it means sodium can lose 1 ion when making a compound with another element. So sodium is going to lose that electron to chlorine. Let's look at the chlorine's valency. So if we go here to chlorine here is in group number 7. So these elements in group number 7 have got 7 valence electrons. So it means if they have got 7 valence electrons, they need 1 electron to fill their outermost shell. So those 7, that 1 has to come from any element that is here in group 1. Here in group 1. Therefore, this tells you that chlorine cannot react with any element here because it will not be stable anymore. So here, the sodium will give that 1 electron to fill this outermost shell. Now it's now filled. Then the valence is already complete. Now this is the Lewis dot diagram for the chlorine. So if it takes this electron and transfers it to chlorine, then it's now stable, and then we end up having sodium chloride. That is how certain ionic compounds are formed. So here you can see that sodium atom has 1 valence electron, and then chlorine atom has 7 valence electrons. So this one can lose that 1 valence electron. This one needs to gain that valence electron. So this is transferred. So ion is just a basic exchange of electrons from this one, which has got only 1, 2 chlorine. So here, sodium now carries a positive charge, Na+, because it has more protons than it has electrons. It carries a charge of Na+. So this Na+, let's kind of differentiate it to the Na. So here in the periodic table, you can see that it is just written as Na. So when it loses an electron, then it becomes Na+. It means it now has more protons than electrons. Remember that the number of protons and electrons are equal. Therefore, when it loses an electron, then it means the protons will be more than the electrons because it only lost an electron. Therefore, this will become the ionic charge for the sodium atom. So this is how the ions are transferred. So let's just look, it continues to say that chlorine now here, Cl now carries a negative charge, chlorine minus. So this chlorine minus, it means it now has excess electrons. By excess electrons, it means it has got gained more electrons than the protons. More electrons than the protons. Remember, the number of protons and electrons are equal in every element on the periodic table. Therefore, if it gains 1 electron, then it becomes a negative here, meaning that it's got many electrons more than protons. That is why in sodium, since it lost an electron, they were equal, but then it lost an electron, then the protons are now more than the electrons. Therefore, it has got an Na+. The plus is standing for a proton, which is in excess for sodium, and then for chlorine, the minus is standing for an electron that is in excess, meaning it is now gained. So here, the ionic bond, you can see that this is the transfer of electrons from atom A to atom B. So this is a reaction. They're supposed to actually put a plus here. You can see that here, this one is actually hydrogen because it's got only 1 electron, and that is a valence electron as well. So this atom A, which is hydrogen, you can see that it's a metal. Atom 1, it's a metal. So ionic bond has to do between metals and non-metals. So electrons are transferred from the metals to the non-metals. Here you can see atom number B. This is not actually the symbol of the atom B. No. The electrons help us to determine exactly how many have we got. So you can see this is the valence shell of B. The valence shell of B is basically this one. They just excluded the first shell because it is already filled, all of it. Its maximum point has been reached. So here, this atom B has got a shortage of 1 electron to be able to maintain 8 electrons. This is the second shell. You can see 1, 2, 3, 4, 5, 6, 7, 8. So now it becomes 8. 2, 4, 6, 8 is because this one is transferred its 1 electron, which is valent here, to this here, so that it can maintain now a stable structure. So B now maintains a stable structure, as we can see here. This is the red electron which was transferred here, as I'm indicating here. And then this A now has a positive charge on top. It's because it has now more protons than electrons because it has lost an electron. So remember, the number of protons and electrons are equal. Therefore, when an electron is lost, then the protons become more. That's why we write plus. And then when the number here, for the same thing for element number B, the number of protons and electrons are equal. Therefore, if it gains 1 electron, then the number of electrons is increased. Therefore, it becomes richly supplied with electrons. It has now electrons in excess. That's why we write a minus. So this minus and plus doesn't mean that it's gaining 1 or gaining 2. No, that is why we actually write like 2 plus. This is not plus 2. Plus 2 will suggest or will depict that we are adding 2 electrons. No, this plus stands for the excess of protons and electrons. So thank you for watching. I hope you understand.